Hello, this session is called Using TypeScript with the ArcGIS API for JavaScript. My name is Noah Sager, and I'm a product engineer on the ArcGIS API for JavaScript team. I'm joined today by Renee Rubalcava, who is a software developer, also on the ArcGIS API for JavaScript team. Let's get down to business. Here is our agenda. We'll begin by explaining what TypeScript is and why you should consider using it. Then we'll go through the basics of getting started and see a real-life demonstration using TypeScript with the ArcGIS API for JavaScript, and then end with some resources to help you on your development journey. What is TypeScript? TypeScript is an open-source programming language that is a superset of JavaScript. TypeScript builds on the successes of JavaScript while improving on its weaknesses. What we mean by superset is that JavaScript code is valid TypeScript code. You could almost rename your JavaScript files to TypeScript files and start using TypeScript today. TypeScript transpiles into JavaScript, which is really just a fancy way of saying that it compiles into JavaScript. The reason we call it transpiling is because TypeScript and JavaScript are at similar levels of abstraction, or similarly distant from machine code. Where do I begin? The best place to start is with the TypeScript website. Here you can find lots of documentation and tutorials and really get your hands dirty with the language. Today, we're going to be focusing on using TypeScript with the ArcGIS API for JavaScript. But for TypeScript fundamentals, this site is a great place to start. If you're working with TypeScript and the ArcGIS API for JavaScript, the next place to go is this guide page. Here, you can find all the requirements for getting started, as well as code snippets and some tips and tricks to enhance the developer experience. This screenshot is an example of a simple file structure for a TypeScript application. You have an index.html file, similar to standalone JavaScript applications, and you also have at least one .ts file, the TS stands for TypeScript, and a package.json file and a tsconfig.json file. These JSON files will be important for configuring the application, which Renee will demonstrate later. Now let's look at some benefits. At a high level, TypeScript is easier for multiple people to work on, easier to refactor, easier to test, can prevent technical debt. Now, the reason we say these things about TypeScript is that if you're typing out interfaces, then you have well-defined contracts between different parts of your application. Thus, it's easier for another developer, or even you in the future, to jump in and understand what's going on. Also note that TypeScript is compatible with every flavor of existing JavaScript. Type support. So TypeScript adds type support to JavaScript. While JavaScript is a loosely typed language, TypeScript can be a strongly typed language. I say can because this can be configured or modified in those JSON files I was talking about earlier. In this code snippet, we see a function that takes two parameters, a URL parameter and a legend parameter. Notice the colon after those two parameters. The URL is of type string, and the legend is of type Boolean. This makes it very easy to use these variables, both for the current developer and anyone who might review or modify their code in the future. Down at the bottom, we see the appropriate types of values being passed to that function. Another benefit of using TypeScript is enhanced IDE support. So this is a similar code snippet to what we saw before, but this time I've assigned the incorrect value type to the URL variable. So now it is an int instead of a string. But since I'm using Visual Studio Code, I can see that it gives me an error message at the bottom where I try to pass a variable of an incorrect type to that function. Fortunately, that error message is meaningful and tells us what the issue is. This can help prevent errors even while you're still writing your code and will save you time when you get to actually test the app in the wild. Another great thing about TypeScript is it makes use of the latest JavaScript features. On the left here, we have a demo theater function, which calls a getQuestion function. The getQuestion function returns a promise, which once resolves, calls another function called question. Now on the right, we have those same functions, or the same functionality, but this time we've made use of async await. Since we make the demo theater function an async function, async for asynchronous, we can use the await method in the getQuestion function to wait until the promise is resolved. The functionality on the right is the same as on the left, but with fewer lines of code. Another cool thing is called dynamic imports or lazy loading, which I think is cool because it has the word lazy right in it. This means that you can have a module that doesn't get required until you actually need it. In this code snippet, we can see an asynchronous function that imports a module when it's called. So if the function never gets called, then we never import the module, and this can save us time and resources. Setup and first steps. So we recommend using Node and NPM to install TypeScript. And a lot of you, if you've been working with third-party frameworks already, you should be familiar with these tools. We also recommend that you install TypeScript globally, and we have the screenshot demonstrating that on the screen, and also to install the ArcGIS API for JavaScript typings. Now, the cool thing about these typings is that even if you're not using TypeScript, they can still be helpful for writing in JavaScript with our API. And yes, we do have typings available for both 3x versions and 4x versions of the API, but the recommended version is to use the 4x version. Now, a few essentials that we want to share with you. So for installing and working with TypeScript, we recommend using the npm install save dev. And for getting the 4x typings and the 3x typings, those are the syntax for how to get those typings installed. So we've regaled you with a lot of knowledge and we've told you why and how you should use TypeScript. But let's hand things over to Renee, who's really going to take us home with a real life demonstration of using TypeScript with the ArcGIS API for JavaScript. Off to you, Renee.
Hey, thanks, Noah. So yeah, we're going to go ahead and build a TypeScript application from scratch today. And to do so, we're going to use Rollup to do the build for us. So first off, let's talk a little bit about the imports, right? The syntax is going to be import module from module path. And this is how you've been able to do it in TypeScript for the longest time. It's also how you could write ES code standard for standard ES modules. Would also look the same. Which brings up the point that you could use either the AMD build under the ArcGIS API package or the ESM build, which is the @ArcGIS core package. I highly recommend that you use the ESM build because it is ESM, so it could be tree shaken by most build tooling. Now, autocasting. We need to talk a little bit about autocasting. Autocasting, if you're not familiar with it, lets you provide us something like strings for a base map, such as streets. And then we create a base map class for you under the hood. So when you access base map again later on, it's going to be an instance of the base map class with all types of properties on it. Now, as of today, TypeScript doesn't support this. The getter and the setter have to be of the same type. There is an issue that might support this in the future, but there's nothing set in stone yet. So as of today, autocasting doesn't completely work with TypeScript. Now, autocasting does work in the constructor signatures only. If you're not using a constructor, say you try to call a method that requires a graphic, you'll have to create a new instance of the graphic for it to work in your apps. But it's still helpful in a lot of cases. It's just that when you want to set properties, you need to be able to import the relevant modules and then new them up. Typing improvements. So we take advantage of generics a lot in the API, meaning that you can create, use generics for collections. You tell us what type you expect the collections to hold, and TypeScript will honor that. Now, it's important to note this is different from the collection of type that you can do with collections. When you do of type, we'll actually create new instances of when you add something to the collection, we'll take that and push it to the constructor of whatever class you told us to use. That's different than generic. Generic just says that you're telling TypeScript, what types you expect the collection to hold. We're not going to new anything up. That doesn't actually impact any code in any way. Just keep that in mind when you're using it. We can also strictly type events. Things like map view on mouse wheel are strictly type. All of the different strings for the events are there. We have advanced autocast for things like colors. So you can use the string red or a hex color, the same for sizes. And like I mentioned before, base maps. We have named base maps that are strings. They're all strictly typed. So demo steps. To get started, you're going to make a directory called tsdemo. You're going to cd into that directory. We'll make a directory called source, and then we're going to create an index.ts file. We'll init the directory with npm init and tsc init. This will create a package.json. It'll also create a tsconfig.json. This is assuming you've installed TypeScript globally, which isn't required. You can install it into the project itself. Then you want to install the ArcGIS core package, install rollup, and then there's a few other rollup plugins you're going to want to install for this project that I'll go over when I actually show you the demo. So the index.html is going to be very basic. We're going to have a view div to hold our map, and we'll have a script tag that's going to import the index.js file. Notice it's a type module because we're going to go ahead and compile the code out to ES files, which are going to be ES module. So with the tsconfig.json, you want the lib option to have ES2019 and DOM. And this is because you might want to use something like a document get element by ID and so forth. You need to have that in there. We'll turn source maps on here by setting it to true. You can always turn them off in production if you want. The target will be ES2019. No implicit any, and this means basically you don't want TypeScript to be able to infer the type of any in your code. You want to explicitly set any. We're also going to suppress implicit any index errors. This has to do with iterating over objects. Don't need to cover in too much detail. Module resolution will be node so that TypeScript can find the ArcGIS core package that you've installed. We have an include property here. That's just telling TypeScript where to find the TypeScript files for your application. So the CSS, we're going to have a style tag in the index.html. That's just going to set up some basic styles for us. And then in the index.ts file, we're going to import the web map, the map view, and the layer list switch. We can create a new instance of the web map, create a new instance of the map view. And then what we're going to do is we're going to create a new instance of the layer list. And we're going to go ahead and create some custom panels on here for the legend inside the layer list. So notice that the event is going to have a property called item. And I'm going to go ahead and type that item as an Esri list item. The __ Esri is a global namespace that you get with our typings. And by the way, the typings are installed by default with the ArcGIS core package, so you do not have to install typings separately. They'll get included with the project. And then we're going to go ahead and add a panel to the list item, and it's going to be of type list item panel. And this is what I meant before, where I didn't want to new up a new list item panel here just for convenience. So I can tell TypeScript, this object, I want you to treat it as the type of Esri list item panel. This is how you can avoid having to new things up, but I would still suggest that you do it most of the time. And then I'll just go ahead and add that layer list to my view. All right, let's go ahead and take a look at this particular project. Okay, so the very basics to get set up with our TypeScript project here is that I've already got my TS demo folder. I need to init this as a package.json. And then I'm going to have to add some modules in here. So I need TypeScript. I'm also going to use rollup and some other plugins. Okay, so we're going to get these dependencies installed in here. Of course, I've got TypeScript, and I add tslib because that's a helper that TypeScript will use to add in any helper modules. Well, not modules, methods and stuff it might need for things like classes or object assigns, stuff like that. That's in there. Now I need ArcGIS Core. Get that going. Okay, so I could at this point init with TypeScript a tsconfig file, but I'll just go ahead and set my own up here. So in our tsconfig, we need to set up a couple, right? So in the compiler options, set up my lib. So these are the the stuff that I'll be using. So ES 2019. All right, I'm gonna add DOM because I'm sure at some point of application I'll be using document stuff or whatever. I'll turn source map to true here. And let me go ahead set the target be ES 2019. Right? No implicit any. Talked about this. Set that to true. Do press. Implicit any errors. True. And of course, I need module resolution to be node. Right? And we want to make sure that we include everything inside the source folder. That way TypeScript knows that's where my TypeScript files are going to live. Awesome. So now I need a source folder. All right, so now in my source folder, let me go ahead and add my index.html. All right, so this is a very basic HTML setup. Div for where map is going to go. My script tag for my JavaScript file is going to get pulled in, and it's an ES module file. So I need to type this script tag as type module. All right, see that here in the doc. It's going to explain it to us what that means. Now I need an index.ts. Go ahead and get that going here. So once again, you can see I talked about this already. So we need the web map, the map view, and the layer list. And you notice I've already got all my typings in here. The typings come with the ArcGIS Core package. You don't have to install them separately. They're part of the package. They're about going and grab it anymore. So here I've got my layer list. I'm going to create, add that to the map. All right, so I need one more thing for this project to work. I need a rollup config file. Now you could do this with TypeScript. You don't. You could do this and output this at AMD instead of ES modules, and it might be a little simpler for you. It's really up to you how you want to do it. I'm using rollup because it's kind of the easiest way to get this done very succinctly. I think, my opinion, anyway. I think it's nice to use rollup for stuff like this. If I needed a lot more, I don't know, customizations for the app, I might use Webpack or something. So let me get this set up. My input will be my source index file. My output is going to be have some information related to the format and the source maps. Now the plugins, just need to have resolve here. So resolve is going to go ahead and load modules using that are inside node modules, right? That's how it's going to be able to find those. And then the CommonJS one is used basically convert CommonJS modules, which have things like const something equals requires something. It'll convert them to ES6 so that they can go ahead and be handled by rollup, because rollup really does shine with ES6. I need the TypeScript ones so I can read TypeScript files and do it. And now here's where the one bit you need to do no matter what build system or anything that you're doing here is somehow copy the assets folder from the ArcGIS Core package to your build folder, right? So wherever you're deploying this, you have to copy the assets. Rollup has a plugin called Copy that I can use. It's going to let me copy everything from the assets folder to a dist folder. Webpack also has a copy Webpack plugin that you could use, or you could just use a regular npm script or something to go ahead and do that copy for you. And then one other bit that is kind of a roll-up specific thing I need to do here is to preserve the entry signature. You know, you're going to get a warning. You kind of just want to keep it all nice and happy. So in my package JSON, I need to add a build script now. Let me go ahead and add that. Bam, there we go. Now I can run build, build. Okay, so now that we've got that, let me go ahead and serve this. npx serve, and I have a dist folder. All right, so there's the demo for our TypeScript application. We're able to write everything in TypeScript, have nice, happy typings everywhere, and build out our app. Now you could go ahead and make this a much larger, more extensive application and scale it up. I would recommend you also add in tooling like Cursor or maybe Uglify to go ahead and add some more minification to your project. Just kind of squeeze out as much performance as you can, and you'd be good to go. Like I said, you're not limited to rollup in this case. I just used it for demo purpose. You can also use Webpack and some other plugins and tooling to get better optimized. All right, so another option you could do to build a TypeScript application that doesn't require using Webpack or Rollup or any of those other build tools is to just write a very basic TypeScript app that'll take advantage of using the ArcGIS API for JavaScript CDN to load your application. So you don't have to download the API or do anything else like that. You can actually output your TypeScript code as AMD and then let the JavaScript API AMD loader load it and take care of all that work. So let's see how you can do something like that. So I'm going to go ahead and initialize an npm package.json, so npm init. I'm going to want to install some libraries here. So I want TypeScript and I want tslib. And I'm also going to want the types for the JavaScript API. So I'm going to install those as well. So let's let those go ahead and install. I need to create some files in here. So let me create an index.html. And I'm going to create an app folder. I'm going to create a main folder in my app folder. So main.ts. And I'm going to create a tsconfig. So I could use the TypeScript command to create that tsconfig for me, but it's going to put some defaults in there, and I kind of already know what I want to put in there, and I'll explain them to you when I get to them as well. So in my package.json, I want to add a couple of, actually I just want to add one build script in here. So I'm going to add a build script, not capital. And that build script is just going to run the TypeScript TSC command to build my JavaScript. All right, awesome. So we've got that done. Okay, so now what I want to do is I need to create my index.html file. I need to put some stuff in there. So let's go over here. I'm actually going to go ahead and copy some stuff I already have on hand. All right, so this might look very familiar to you, like you're building a regular ArcGIS API for JavaScript CDN application. Except what I'm doing is I'm going to configure the API so that I can look at the for packages under an app namespace, and that app namespace is going to be wherever my application is running. If you don't do this, it's going to try and look for it under the arcgis.com URL, and of course it doesn't exist there. You're building it inside of your own host wherever you're going to push this application. So you need to do that, and then we're going to go ahead and require the app main file, which is going to get created from the API. So by adding the script tag here, we're going to have the AMD loader available to us for our application, and we can get going with that. So okay, so this is a very basic HTML file. Let's go ahead and work on the tsconfig, because if I try to write my TypeScript right now, I'm going to get a bunch of errors because my tsconfig is not set up. So let's go and do that. Okay, so here's my tsconfig. The key part here is that I want the module output to be AMD. This is going to create an AMD file that I can then use to load, use the AMD loader from the JavaScript API to load my app. Some of these are just settings that are very basic. For example, no implicit any, meaning that if I do have type any in my TypeScript code anywhere, I am explicitly setting it to a type of any. ES module interop will be true, and this will just kind of, if I want to load JavaScript modules that are not TypeScript, it'll go to work that way. I want source maps. If I were going to do any kind of widget work, I just kind of keep these in here by default, because sometimes I might want to do that. You might not need it if you're just building a very basic application, though, so you would be fine. The target in our case is going to be ES5. This might change in the future. You might be able to output the target as like ES 2019 for this particular situation, but as of right now, because we're going to AMD, I need to leave it as ES5. But like I said, this could change maybe by the time you're watching this video, that you could set it to ES 2019 or more. Experimental decorators, I'll leave this as true, just it's nice to have. Preserve, const enums, I mean, this is just interesting to have too. And the rest of these are just kind of basics that you would have. So I want to include any files inside the app folder, but I don't want to do anything against my node modules, right? I don't need that. So now that I've told it to include any code in my app folder, I can start writing code in my main TS file. So what I'm going to do is I'm going to import ArcGIS map from Esri map. So I've got my IntelliSense in there, so I know my typings are working. I'm going to import map view from Esri views map view. Awesome. Now I can create my map. My map is going to be equal to a new ArcGIS map. And let's go ahead and use a base map, a base map here for the streets vector. All right, that's pretty straightforward there. I'll create my views. So const views equal to new map view. I'm going to pass the map I created. My container will be the view div, which is part of my index.html. The center will be somewhere over the alley area, like so. And I'll have a zoom of 12. All right, then I'll just have a small little, when view.when happens, I'll just console.log out a little message so that I know my view is ready. So I do a console.log. View is ready. Awesome. You notice that there are no errors. Everything works because I told tsconfig that anything that falls under the main TS folder, falls under the app folder, any TypeScript in there, I want to apply these typings to it. So as I saw here, I've got my build script in here. So I now, at this point, I should be able to go ahead and run npm run build. And it's going to create a main.js file for me. And this is the AMD code that you would have normally written if you were still writing regular JavaScript, working with the CDN. This is kind of what a module would look like, which is really interesting. So that's all set up. If I wanted to do this in like a dev mode, right? So maybe I want to have a start command in here. I can do tsc-w. Right, so now what I do, if I run npm start, so it's going to start compilation in watch mode, meaning I can now come in here and maybe I want to change this to be topo vector. So we go and make that change for me, and I can check the main.js file, and I can see that the map, base map has been updated with topo vector. So I go back here and change it to streets vector, and I'm good to go. It's going to update that as well. So this method and flow of development is perfectly valid. So let's go ahead and see what this application looks like when I run a small local server. All right, so here's my application running on a local server. It's over the Whittier area, which I just happen to know the lat long for. And if we look at the network traffic, all of the modules from the JavaScript API are coming from the CDN, except for my main file, which is coming from my local host. So this is how another method that you could use TypeScript to build your applications, but still take advantage of the CDN with a very basic workflow. And this is probably the most minimalist and simplest way that you can take advantage of TypeScript to write your apps. I also want to point out that everything that I discuss here, you can read in more detail in the ArcGIS API for JavaScript SDK. We have a section under developer tooling, setting up TypeScript, which is going to go through all these steps that we talked about in more detail and lay out exactly why you would do certain things, right? So please check out this documentation. We put a lot of work into it. So please read this documentation. It'll help new developers that are not familiar with TypeScript using the JavaScript API, and really for any developers that want to take advantage of TypeScript for building apps with the JavaScript API. This tip is for VS Code. Basically, you can reduce clutter by hiding any JavaScript files that have a companion TypeScript file, and also remove any JS map files. So any of the map files that get created when the TypeScript does its build, you don't want to actually view those. So you can exclude them in VS Code in the user preferences under files.exclude. So this is how you can do it here. This is pretty straightforward. And what you're saying here is that any JavaScript file, I don't want to actually see it in the browser of VS Code, and I also don't want it to show up in my searches when there is a companion .ts file. So debugging with source maps, so you want to enable source maps in the browser DevTools. This way you can go ahead and set breakpoints inside the TypeScript file instead of the JavaScript file. This is really useful for debugging. So where can you get more info? We have a lot of information on our SDK documentation related to TypeScript and getting started with TypeScript. We have Esri related training and webinars you can look up, a ton of blogs on the ArcGIS site that you can look at, as well as GeoNet, Stack Exchange, and more. The picture below is from a blog that Noah and I wrote on using TypeScript with the ArcGIS API for JavaScript. And thank you very much for coming to our session today. I hope you learned a lot about TypeScript and are excited to get started with it.